Hey guys, welcome to today's lesson. We're going to go ahead. Obviously, you have your Do Now completed. You've got your Chromebook out. You signed on to Neo, and you're ready to take a look at our objectives today, which are identifying chemical properties. What are they? And be able to give some examples. Plus, being able to explain how we can use chemical properties to identify some different materials. So we're going to end with a little virtual lab. Right now you should go ahead and have your section 4 notes in front of you. Chemical properties and materials. You see a picture of what we call a spectrograph of helium. The top you see from the sun, and another one in comparison below it, and we'll talk about what that means in a minute. Let's go ahead and start with the first section. First part, chemical properties. What is a chemical property? A property of matter that describes a substance's ability to participate in a reaction with another material. So we're focusing on what happens when they interact with another, and that means that it is a social behavior. Physical properties, personal behavior, something belongs to them. This one responds to other things. So when we have a chemical property, you're going to need a chemical reaction in order to observe it. So they have to be interacting, doing something in order for us to see it, to recognize it. Each element has its own chemical properties, and therefore, when they're combined, even with other elements and compounds, will have distinct characteristics. Okay. When we're looking at physical property, we're really looking about what happens, or how does that particular element change into a new substance, either by combining with another element or disconnecting, breaking down into its single element again. So look at chemical properties. A couple of examples that we have for chemical properties. First is obviously going to be reactivity. Okay, reactivity means the substance ability to combine chemically with another substance. We have talked about noble gases already. They are significant because they're non-reactive at all. So that's part of their properties there. No reactivity. Another one would be the group 1 elements that you see here. We got lithium, sodium, potassium, rubidium, cesium, francium. These elements are known particularly because they are so reactive. They have the most reactivity on the periodic table. Well, with the exception of fluorine, but we won't worry about that because we're not in chemistry right now. If you want to take a look and see at some reactivity, some reaction of these different elements, I have attached in the NEO lesson a quick video going through the different alkaline metals and seeing what happens when they come in contact with water. So you can take a look and see what happens with our least reactive lithium, and then as we go down the sphere, that is on the NEO lesson 4 if you want to take a moment and take a look at it. Another example that you guys are probably pretty familiar with would be flammability. Okay, it's the ability of a substance to react in the presence of oxygen and burn when exposed to flame. Okay, so flammability. Some of you got to see that yesterday when we took a look at the sulfur. Some of you did catch a little bit of your sulfur on fire. Nothing big, so we didn't get to see a big one. I will try and do another demo when we get back from this. So flammability is a big one for safety, though. So that's something we really need to consider, and it's really important on an MSDS sheet because that's what we see happening. Another example, you see here the Statue of Liberty in green, as you know her, but next to her is the Statue of Liberty in copper because she actually is made out of copper. So why is she green? Well, it's a response to copper's corrosion. So other examples of chemicals property would be what happens when they corrode. So corrosion, rusting, oxidation, we're going to spend time on that specifically when we talk about metals. It's actually our transition unit between metals and ceramics, so we'll spend some time on what happens when each of them are exposed to other chemicals. As you can see, copper turns green. Something else you're probably pretty familiar with was acidity or basicity. You know, what level are they on the pH scale? That's another example of chemical properties. Or even how do they react with acids? So some elements don't react with acids, at least not noticeably, while others, of course, will react when exposed. Or we can just talk about an acid-base reaction. That's something that we do in chemical properties. Another example would be spectrophotometry. This is a spectrograph, very similar to the one that you saw on the first page. It's sort of the opposite, though. The first one is a spectrograph where parts are missing. This is a spectrograph where we highlight the different parts. As you can see, this says helium up here. Okay, what they have done is put a tube full of helium gas into an electrode, so it lights up like a neon light, right? But if you notice that there are only certain colors available, they make a distinct pattern compared to the sodium neon spectral lamp right there. So this is sort of what sodium, each element has its own distinct spectrograph. When it burns, okay, when electricity is sent through it, when it lets off light, we talked about this when we talked about the glowing material, the phosphorescent material. This is the same idea. Electrons are excited, they jump up energy levels in the atom, and then as they jump back down, they let go of light. Well, in this case, each atom, how much light, what type of light, red, green, blue, yellow, that sort of thing, is specific to each of the materials. So this is very similar to what you'd be doing today with your flame test lab, and I'll show you how we're going to do that in a second. Before we do that, however, let's go ahead and finish up your notes. We've been spending time with physical properties, specifically mechanical properties. Now I'll take a quick look what the difference is between the two. Physical properties, we can do those, we can observe them without any reactions. I obviously mentioned earlier, you usually need a chemical reaction to see the chemical properties. These guys, you don't need to do anything special to them, okay? Whereas the chemical reaction, like I mentioned earlier, is a reaction to other substances. It is a substance for seeing what's being made new, either by combining or disconnecting with other elements. So of course, when you have a chemical property involved, you actually do have a second substance there in order to observe it. So those are your two major differences between physical property and chemical property. Last but not least, let's go ahead and take a look at what you'll be doing today. You should be getting a handout on a flame test lab. Okay, so first things first, here's your flame test. This is the link that you should see this picture when you get to the link, okay? And you have a little flame test set up for you guys. So I'm sorry that we weren't able to do this actually in class, but we can still get to see the parts of it. First thing, nice instructions on the video. Click up, it says click on the wire loop right there. So you're going to go ahead and click on the end here, and you're going to wash it off first. Or there we go. Sorry, not the end, the middle. And stick it into the water, and it cleans it for you. Okay. Once it's cleaned, then you can go ahead and put it into your different baths with your different metal ions. Because you're going to be looking at is how do metals, such as lithium, respond to flame. And you can see that lithium has a bright red flame. So when it burns bright red. When I get back tomorrow, we're going to talk about colored candles as well and how we use them. Once you have that flame in there, you're going to go ahead and write it down on your paper. Rinse off your metal ring again, and you're set to do the next one. So you're going to take a look at all of those different metal salts and create metal ions with them. And then your very last step is to take a look and see what happens or which of those metals is in that unknown substance. So you're going to have to identify it. So not too bad, quick and easy. If you have any questions, ask around, see if your neighbor can help you out. And I hope to see you guys all back tomorrow. Have a great evening. Bye.